Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, I hope you will be fine and healthy staying at your homes. I am Ms. Khaulah Aamir, and we will be studying the new chapter of chemistry, that is the structure of molecules, part 1. So in this lecture, we are going to discuss about the chemical bonds or chemical forces, a brief introduction of them basically. Then we'll discuss what are the different reasons that atoms have to form chemical bonds and how do they do it. Then the definition of chemical bonds, its types, and the role of attractive and repulsive forces in chemical bond formation. So everything is basically made up of matter, whether it be solid, liquid, or gas. So all matter is composed basically of atoms. Even we are made up of atoms. So how do atoms do it? How do atoms form different types of matter? The answer to this would be the chemical forces or the chemical bonds which are responsible for holding them together in a substance. So how do atoms, or why do atoms form chemical bonds? Atoms have to achieve stability by following the octet or duplet rule. We know that having 8 electrons in the outermost shell means the octet rule, and having 2 electrons in the outermost shell is basically the duplet rule. So in this regard, we have to keep in mind that atoms have to follow the electronic configuration of their noble gases, right? So we all know what are noble gases. Noble gases are the elements in the periodic table in the 18th group which have their octets and their duplets completed. So atoms basically try to follow their electronic configuration, right? So in other words, you could say that atoms are basically following the noble gases as their role models for to complete their octets and duplets and follow their electronic configuration. So as you can see in this example, we have 3 different noble gases, that is helium, right? It has 2 electrons in its outermost shell, so that means its duplet is completed, right? Then is neon. Neon has, you can count 1, 2, 3, 4, 5, 6, 7, 8. That means its octet has been completed, it's also stable, and so is argon. If we count its outermost electrons, that is 1, 2, 3, 4, 5, 6, 7, 8, right? So that means these gases have their octets and duplets completed, so they do not have to react with anything, right? So other elements in the periodic table are not the same. They have either 1 electron missing, or 2 electrons missing, or 3 or 4 or 5 or 6 or 7, up to so on. So they have to fulfill the deficiency of electrons to complete their octets or duplets in order to become stable. So now that we know the reason for an atom or different atoms to combine with each other, we are going to study how do atoms form chemical bonds. So we all know that in order to complete their octets or duplets, atoms have to combine with each other, and this phenomenon is known as chemical bonding, which holds them together in a substance. So for chemical bonding, atoms have to give, take, or share electrons from other atoms to complete their octets or duplets. If the valence electrons are less than 3 in an atom, the atom donates those electrons because it is more feasible for that atom to do so. If the outermost electrons are 5 or more than that, that means that atom has to gain electrons because it is more feasible for that atom to gain 3, 2, or 1 electrons rather than losing all 5 electrons altogether. And the last option is to share those electrons with other atoms. In this example, you can see that the periodic table has been shown, in which the valencies are written at the top of the groups after losing or sharing electrons. We all know, for example, in group number 1, all these elements have 1 electron in their outermost shell, right? So it is more feasible for these elements to lose that 1 electron and become the state of valency +1. Similarly, in the second group, we can see, since second group contains 2 electrons in the outermost shell, so rather than gaining 6 electrons, it is more feasible for the members of group number 2 to lose those electrons and become the valency of +2. Similarly, group number 18 has 0 valencies, 17, 16, 15, 14, and 13. You can see here. And these valencies have become possible only after losing or gaining electrons. Alright? So, what is basically a chemical bond? It's a force of attraction that holds the atoms together in a substance. It's basically a kind of glue which makes it possible for the atoms to stay together in a substance. Imagine if a solid is there and it starts vanishing into the thin air. It's not possible, right? Why is it not possible? Because all the atoms in that solid are glued to each other by that chemical force or by that chemical bond. So there are different types of bond formation. We'll have a quick look on about these. So first is the ionic bond. As we know from the name that ionic bond is derived from the word ion. So how are ions formed? We have already studied about this in chapter number 1, in which we studied about the formation of a cation and anion and different examples of those. So in this example, you can see that sodium atom has 1 electron in its outermost shell, right? Since it belongs to group number 1, in order to attain that oxidation state of +1, sodium requires to give that electron to chlorine, right? And chlorine has 7 electrons in its outermost shell. So after getting that electron, the oxidation state or the valency of chlorine becomes -1, right? So when these two ions are held together, and this type of attraction will be known as electrostatic force of attraction between the opposite ions. We all know that unlike charges attract each other, right? And like charges repel each other. They do not come close to each other. So sodium has become a positive ion after losing that electron, and chlorine has become a negative ion after getting that electron. So both are oppositely charged now, and they will both be attracted by each other through electrostatic force of attraction, and a new compound will be formed, which is known as sodium chloride. Another is a type of bond that is the covalent bond, and we have also studied about it a bit in the previous chapters. So in this type of bond, there is a mutual shedding of electrons. When electrons are not in a position to gain or lose electrons, they start to share those electrons. For example, you can see here there are 2 hydrogen atoms and both have 1 electrons in their outermost shells. Obviously, it's not feasible for any of those 2 hydrogen atoms to either completely lose those electrons or completely gain electron from the other atom, right? So what they do, they come closer to each other and they start sharing those electrons. Now these electrons are basically, they belong to both atoms. So in this way, both of their doublets have been completed. In this another example, I would like to show you the bond formation between 2 different types of atoms, that is the hydrogen and chlorine. Here you can see that hydrogen has only 1 electron in its outermost shell, right? And chlorine requires only 1 electron to complete its octet. So what they will do, it is more feasible for both of them to share those electrons, and in this way, hydrogen will share its only 1 electron with chlorine, and chlorine will share its only 1 electron with hydrogen, and both will combine to form a new compound which is known as hydrogen chloride. So, in the last, I would like to discuss the role of attractive and repulsive forces in the bond formation. When 2 atoms approach each other for the purpose of bond formation, they do not immediately start to form a bond. What happens in the first part is that both atoms are under the influence of 2 different forces, the repulsive forces and the attractive forces. The repulsive forces, obviously, how do they come across these repulsive forces? Basically, between the like charges. Now, where are these like charges coming from? We know that electrons are present in both the atoms, right? And both have negative charges. So these repulsive forces basically will be responsible for keeping these two atoms far away from each other, right? Similarly, there is another set of repulsive forces between the nuclei of these two atoms, right? Both have positive charges, so these two positive charges will start to repel each other, right? But at the same time, there is a type of attraction between oppositely charged subatomic particles, that is between the electron of one atom and the nucleus of another atom. Similarly, the electron of one atom and the nucleus of another atom. So, to cut it short, I would like to make it clear that basically these two forces, if one of these two forces is dominant, this dominance will basically decide whether a bond will form or not. Obviously, if there are repulsive forces which are stronger than the attractive forces, then atoms will not be able to come closer to each other and the bond will not form. But if the attractive forces come closer, are very stronger as compared to the repulsive forces, then that means that the atoms can come closer to each other, and when they will come closer to each other, they will basically form a bond. So at the end of this lecture, I would like you to answer all of these questions. I have given the answers in the parentheses for your practice, but in the upcoming lectures, you will have to find the answers by yourselves by reading the text in the book. So all these questions are very important for your examination point of view, so please learn them by heart very well and do excellent written practice of all the topics that have been discussed. Jazakallah khair.